welcome everyone. Thanks for taking the time today to come to this Network Testing 101 with Cisco Pi ATS. So this is the agenda for today. The whole thing around today is just kind of giving you an introduction to what Pi ATS is. So my main goal is to give you the code and the knowledge to quickly get up and running with it and to dive into it further if you want to. So we're going to look at what Pi ATS is. We're going to look at some of the use cases you typically use it for. We're going to look at the main Pi ATS components and also the main Genie components. We're going to do then a quick comparison of how the Pi ATS framework would compare with using something else for network testing, which something like Pytest. And then we're going to dive into a couple of demos. We're going to first of all use Genie Parse with Pythest and Rich to create a interface error report. And then we're also going to create a maintenance Diff tool using Genie Learn and Genie Diff. But the key thing with this last demo is we're going to do all of that not within Python. We're just going to do that within the Pi ATS CLI. So there's kind of two different options there. So that's also going to be a good demo for any folks that haven't got any Python experience and you just kind of want an easy segue into network automation and network testing. Good stuff. So who am I? So I'm the founder of Packet Coders. So I'm a network automation architect and trainer. Background, network security, ADC, lots of stuff, automation, SDN, that's all good. You can follow me over in Twitter. That's my handle there. But who are Packet Coders? Well, Packet Coders, so it's a network automation learning platform. We do on-demand training, instructor-led training. Find us over on Twitter at that handle. And that's the website address there if you want to learn more. Cool. So let's dive into Pi ATS. So what is Pi ATS? So Pi ATS is it's a network testing framework. So it was developed by Cisco originally just for their internal testing. And then they open sourced a majority of it, but not all of it to the public. So it's all about network testing. It's a Python-based framework. And what it is it provides you with a set of, various libraries and parsers, everything that you need to test your network. So you can see Pi ATS as an all batteries included stack. And the reason I say that is because you get everything. So you get all of the connection and device drivers. So think that Miko, you get the testing framework. You get various helper libraries for multiprocessing, etc. You get various other libraries for helping with the parsing, lots and lots of different things within this framework. So you've got everything available to you. So on the right-hand side, this is what we've got in terms of the Pi ATS stack. So we've got the stack is basically this part here. So first of all, we have the Pi ATS core. And this includes your inventory, which is called the test bed. So the device is under test. Things such as your device interaction, your device drivers, also various other libraries for the test runtimes and reporting, etc. And then on top of that, we have Genie, and Genie consists of various libraries that helps us work with this data that we're getting from the network via the Pi ATS core. So things such as parsers, diff tools, various libraries, DQ, I'll talk about that a bit later as well. So we get lots of libraries within Genie as well. So we've got these two main components, the Pi ATS framework. Now on top of that, outside of the framework, there's various integrations that are available. You've got Ansible roles, you've got the robots framework integration as well, but that's outside of the scope of this session. So some of the use cases you might want to use Pi ATS for. So there's two things for me that come to mind. One is just running tests against your network to validate it's running as expected. So you might want to see if you've got certain prefixes within your routing tables, that you've got your nodes versions of a certain version, no interface errors, etc. Or you might want to diff your network. So you might want to validate that your network is running as expected against a golden state or a state prior to a maintenance and some changes that you've made. So you kind of got there's two main use cases there. So let's dive into the different Pi ATS components. So we've got the main components here. There's lots of other things within the Pi ATS framework, but if we get these core components under our belts, then everything else is going to make sense. So we have Unicon, which is the device driver for connectivity out to the network. We have our test bed, And our test bed is all about the devices that are under test, and that's going to contain credentials, IP addresses, slightly synonymous to like an inventory within Nornir or Ansible. Then we've got all of the different libraries within Genie. So we've got Genie Parse, Learn, and Diff. And so those are the tools that we're kind of going to interact with. And then we've got various Genie parsers as well. So those parsing templates to be able to then convert, in the case of going out to devices via a CLI, convert that raw text into some structured text that we can work with easily within Python. And then on top of that, we've got AETest and EasyPy. Now, these two libraries, these are the libraries that provide the test framework and the runtime. So test framework, it gives us that framework to be able to build tests in a nice structured way. And with the EasyPy is going to then give us the test runtime that's going to allow us to run all the different tests in one job. And it's also going to give us the ability to do other things such as alerting, i.e. sending out email notifications or generate HTML reports. So we've got these two bits here. So what we're going to cover today is we're going to have briefly look at a test bed. We've got one of those in our example, but we're going to look at using the Genie Parse and also the Genie Learn. And also, yeah, we've got the Genie Diff in there as well. So we've got quite a lot of stuff to dive into. Cool. So let's look at the Genie components. And it's really, I would say, learning the Genie components is one of the fundamental things to really help you navigate the Pi ATS framework. Because when you look at Pi ATS and you go onto the documentation, there is a lot of different things in there. And it's really easy to get overwhelmed and to not know where things sit. So you kind of need to place all of these different components to kind of navigate your way through learning the framework. And Genie is the key and one of the main things to kind of figure out. So when it comes to Genie, we've got four main components. We've got Genie Parse, we've got Conf, we've got Learn, and we've got Diff. And they all do slightly different things. So what we've got is, first of all, we've got Genie Parse. And what Genie Parse does is you run a command on a device and it will take the output and it will send it through some Genie parsers to get that into structured text, right? Because what you don't want to do, you don't want to be trying to test your network from pulling out strings from a kind of a blob of text. It's just going to be a nightmare. You want it in some kind of structured text coming back so you can work with it, so you can pick out the keys, the values, etc., etc. So that's all good. So we've got Genie Parse. Now, on top of that, we've got Conf and we've got Learn. Now with Conf and Learn, what these tools do is Learn basically allows you to learn about a protocol or a feature. So what this does is this will go off. So say you learn about OSPF, you can learn about OSPF, interfaces, routing. It's going to go off, and at the point you do a learn, it's going to go off and it's going to basically run a whole bunch of commands. It's going to get all of the output from those commands, send it through the Genie parsers, but then construct this kind of mega payload for that learned protocol or feature. So then you're going to have this massive payload of data that you can work with for what you've just learned. You've then got Conf, and what Conf does is Conf then allows you to configure devices just using a common set of methods and objects within Python using Genie. So that's all good. We're not going to cover that today, but you've got Conf. Now, the key thing I would say about these two is that they use models under the hood to define the different commands that they run on the back end. So first of all, Conf and Learn only are available for Cisco-based devices, and they use these Genie models. And so when you go on to the documentation and you go within Genie and you look at models, you'll see Conf and you'll see Ops. Conf relates to Genie Conf, Ops relates to Genie Learn. And then when you dive into that and you dive into these documents, you'll see all of the different commands that it runs for each of the different devices based on what you're using. So that's how to kind of navigate that documentation. Then we've got Diff, and what Diff does is it allows you to diff different objects, because you can work with the Pi ATS framework within Python or by the CLI, which I'll show you in a bit. And so you can diff different result objects from within Python, or you can actually diff files from what you've generated from just using the Pi ATS on the CLI within the shell. And that's the example that I'm going to show you in a bit. So we've got these four main components. Cool. So before we dive in, what we're going to do is we're just going to quickly cover what the difference is between Pi ATS and Pytest. So as I mentioned, Pi ATS is all batteries included. You don't need anything else. It's all good. Pytest, on the other hand, Pytest is basically it's a framework that deals with it's all about the runtime, and so it gives you a CLI, gives you discovery, but it's all about kind of running your tests and allowing you to build them in a structured way. So when you compare this to something like Pi ATS, you can see it just as the same as AETest and EasyPi, right? That's the comparison. If you're building a network testing stack using Pytest, you have to bring in something to be able to connect to the devices. So either, NetMiko, and then you have to use parsing libraries, or you might bring in something else and connect out to some REST APIs, something like the Arista Pi API. So, and then you don't need to do any of the parsing, it comes back as structured, but you've got those two different things here, right? And that's the main takeaway. This is all batteries included, but if you build in some other stack, so something like Pytest, a Pytest testing stack, you then need to bring in all of your different components. But it gives you a little bit more flexibility when you use Pytest, because then you can bring in things like Batfish, CVQ. So, there's always a bit of a trade-off, right? So those are the two main differences. Cool, great. Slides are done, which is what I wanted to kind of get through. And then so we can kind of get into the real meat of things and step through the code. So what we've got is I've got a repo here, which I've created with a set of examples. So what you'll find is if you go to this link afterwards, so everything I'm going to run through, you'll have access to. So I've just made this, actually this is still private at the moment. I'll make it public after the webinar, but this has got all the examples we're going to cover, and it's also going to tell you how to set up the different examples and get this running from your side yourself. So that's all good. Now the examples that I'm running today, it's just going to be against a little spine and leaf topology. I've got some Nexus devices in there, some iOS devices, some other devices as well, which we're not hitting. So don't really need to talk about them at all. So when it comes to Pi ATS, to install it, I've already got it installed. What you need to do is just do a pip install Pi ATS full, and that's going to install everything. You can prune things down slightly. There's a couple of different ways you can do that using the different pip syntaxes, but yeah, you can just do that, and that's going to install Pi ATS. There's a couple of other things you can use as well. You can actually run a Pi ATS version check and use outdated to see if any of the packages, if there's anything new out there that you need to install, which is quite nice. And you can also do a version update to actually then perform the update, which is all good. So I've already got this installed. I've got this within a virtual environment. The steps for creating a virtual environment, etc., are all within the README for this repo. And also all of the requirements for what we're going to use today, also in the requirements.txt, which you can install. Again, all the steps are within the README on that repo. Cool. So before I show you the demos, what I'm going to quickly say is that when it comes to Pi ATS, there's two kind of methods of interaction. We can do everything in Python, but we can also do everything through the CLI. So there's a Pi ATS CLI, like so. And this is going to give you, all of the different things, a majority of the different things that you want to do. Personally, for me, I think this is quite a killer feature, because it means that you can go to, if you've got anyone within your team, they've not yet learned Python, you need a real easy segue, and you need to get some quick wins for testing your network and to make sure things are working as expected. This is going to give you that. So it's a kind of real good takeaway from the framework. Now we'll cover how you work with it with Python in a minute as well. But before we do, what we will do is we'll quickly go into a testbed. So I spoke earlier before about the testbed, and the testbed contains all the details of who we're going to test, right? And how to connect to them, and what protocols to connect to them on, etc., etc. And that's what we've got here. So to create your testbed, you can do it manually. There's a couple of other options as well. You can export this in from an Excel spreadsheet. So there's some helper options, which you can use via that Pi ATS CLI. And there's also an interactive option where you can kind of go through line by line and say, this is my IP, this is the name of the device, etc., etc. But we've got this here. Now, obviously, if you're using this for your own environment, you're going to need to change this slightly because this is for my lab, but yeah. So a few things to point out. First of all, we've got the names of each of our devices. We've got the connection details, how we're going to connect out to the devices. So the IP address, the port and the protocol. Now, the point that I wanted to make here is that you don't always have to connect out to everything via SSH and then do the parsing. There's some additions that you can use within Pi ATS to reach out to devices just using a REST API, which is kind of nice because then you don't have to go through all of the parsing, etc., that I spoke about before. And then we've got the credentials here. So this is going to pull this from our environment variables. Now, one of the things to mention is this syntax here. So this syntax isn't YAML, right? This is a string, it's denoted here. So this is a Pi ATS thing, but this is basically going to say pull for the password, take it from this environment variable. Okay, so that's one thing to mention. And I've got the environment variables stored here within my .env file. So that's all good. And I've got an example here that you can use. So we've got our testbed file with all of our devices. Let's close that down. Cool. So we're good to go. So we've now kind of got our testbed file of who and how to connect to these devices. And so we can dive into a couple of examples. So the first example is what we're going to do is we're going to build a small script to use a Genie Parse to go out to just our Nexus Spine devices, pull the data back from a show interface. Then what we're going to do is going to parse that into structured data. We're going to take that data out, and then we're going to use the rich Python library to display this in a nice pretty table. Okay, but the other key thing here is we're going to do this via and use the multi-processing features of the framework, right? So that's another benefit here. So kind of a lot of things that you can kind of take away from this, and also it gives you a real nice stepping stone if you want to extend this out and just use it within your own network. Good stuff. So we do our imports like so for the various things that we want to use. So we've got rich here. We're going to use this for doing some filtering within the Pi ATS testbed. We're going to use our DQ from our Genie utils. We've got Genie for our testbed. Now we've got a library here which is load.env. Now this is a good tool because basically what this does, when I do load.env, it's going to load the environment variables from this .env file, and it's going to make them available to me. It's going to make them available to that testbed file that you saw a minute ago. So if you want to install this or look at it, it's on PyPy, it's called python.env. Okay, so that's how you just do a pip install python.env, right? So you want to look that up. It's a good tool. It's kind of one of those libraries that I use pretty much for everything I do within Python. What we're going to do, we're going to load in our testbed like so. So that just points to that YAML file that I showed you a minute ago. And what we're going to do within the testbed file, we're going to find the devices. I'm going to find the devices with an OS type of Nexus. So it's going to basically give us 2 devices back. Now at that point, this is going to be a list of our devices. And then we're going to pass that into our testbed.connect. And what this is going to do, this is going to then connect out to all of the devices, but in a kind of parallel based execution and via multiprocessing, right? So there's some things that you can do against the testbed that use the multiprocessing features out of the box, right? So you can use within Pi ATS, you can use the pcall library, which gives you multiprocessing, but there's things that within the Pi ATS that is baked into. When you connect to the devices, that's one of them. And the other thing that we're going to look at now is parse, right? So that's actually also going to use the multiprocessing features of pcall out of the box as well, right? So that's nice. We've connected out to the devices, and then what we're going to do, we're going to parse all the devices within our testbed. We're going to parse the output from show interface. We're going to pass in the devices that we want to do that against. Now that's this point when we get this data back, we are going to get lots of kind of like nested data. So to kind of filter this data down a little bit more, what we're going to do, we're going to use DQ. And all DQ is going to do is going to say, kind of give me all of the paths to this key. It's going to give us the value as well, because within the script, we're just going to be showing the out discards. Now, some of the interfaces, so like the SVIs and some of the loopbacks, they're not going to have out discard counters. So I don't want to go through the monkey dance of having to go through like, if you can't get this key, then give us a nut, then return a none and all this kind of rubbish. I'm just going to filter it down. So I've just got a kind of nice clean output. And at that point, I've got the output in a nice clean structure. I then can create my rich table. So rich is a nice framework for displaying data. And I'm just going to give the table a title. I'm going to create a number of columns. And then all I'm going to do is loop over the data I get back. And each time adding a row. So adding a row to that table with the device, the interface name, and then the counter information, right? Which I'm pulling out from the counters out discards. Don't have to worry about that key being there or not, because I've filtered this through DQ. And then we're just going to use the rich console and the console print out the table. So how that looks, so if we run this, this is going to go out to our two devices. And then we've got this table here, right? So it's kind of rightly or wrongly or good or bad, it's shown all zeros. Maybe it would have been a bit better if there was a few errors in there, but we've got our two devices, right, that we've filtered out. So, you know, this is quite an easy script. If you want to kind of then start adding in the other errors, you can do. Just you can do that. It's quite a nice tool. You could throw it into, you know, make a quick CLI out of it. You can extend that out, and it's quite a nice way to be able to kind of visualize your data. So if you want to do that and you want to work more with it, what I would say is just do a from Rich. Use print of the rich library. So the rich library is just a really, it's just a really nice library for kind of visualizing and prettifying all of your output. We could stick in let's do it here. So we do our print, and let's have a look at the output quickly. So let's say you're like, hang on, this is all right, actually. I want to get in a few other errors, and I want to kind of add these to create some other columns. You could then just kind of add this into your script. Run this again. And you can kind of see all the data that you're getting back. So this is all the data that we've parsed. We've got the raw data back, and we've parsed it through those Genie parsers. And this is that data that we've got back. And this is the data we can work with. This is before it's actually gone through DQ. So we've got all of this data that we could work with. You could then use DQ to filter this down, get some other counters out. And then kind of add an additional column in and add your data in here for other errors that you want to add in. So we've got that there. So the other thing I wanted to show you is Genie Diff. So let me clear this down. So what we're going to do within this example is we're going to basically do like a really mini fake maintenance. And the whole point of these scripts is that we're going to use and work with Genie Diff via the CLI. What we're going to do is take a network snapshot, but we're going to use Genie Learn. We're going to learn about a number of features. We're going to learn about OSPF. We're going to learn about routing. We're going to learn about the interfaces. We're going to get all of that data back. We're going to store that within some files. Then we're going to make our network change. We're then going to do take another snapshot of the network. And then what we're going to do is going to compare that pre and that post to see the changes that have happened and see what the differences are. So if we look at these here, these are the scripts. So within our script, what we're going to do is, because we need our device credentials, right, for that test bed. So I'm just going to export them in by catting out that .env. That's going to bring in all of those environment variables. I'm going to just set our Pi ATS path. And this is the main bit, right? We're going to use the learn feature of Genie. So this is that Genie feature. We're going to learn about these features, OSPF routing and interface. So each one of these, when we go out to each of the devices, actually going to run a whole number of different commands. We're going to do it on these devices, these 4 devices. We're going to use that test bed file that we saw before, and then we're going to store the data within this location. So if we quickly run this, cool. So let's run that. Okay, so we've got this here, and within this pre-folder, we've got a whole bunch of different files. And so what we've got is we get the connection details on the devices, and then for each of the features that we've learned, you can see we've got the interface here for this device. We get the console output, so basically just the output and the commands that are run for each of these features, and that raw output before it's actually been parsed. And then here, so this is multiple different commands and the multiple different outputs. This is the result of the Pi ATS learn parsing that into that one big data payload. So you can see here, right? So we've got all of this data, so it's quite chunky. And we've got that here for each of the devices. I think OSPF is a particular long one. If you look at the console, you can see all of the different commands that it runs. It's a whole bunch of different commands, and looking at that output, got a lot of data in there. It's quite nested, which is where DQ comes into play and helps you out. So we've got that there, so that's all good. So let me quickly make a change on the spine one. So what I'll do is I'll take down one of the interfaces. So the maintenance has gone terribly wrong for whatever reason, and I've taken down one of the interfaces to basically one of my leaves. So I'll save that. All right, so we've done that. So let's now take another snapshot. Yeah. So the only difference with this script is basically we're doing the same as what we did before within this pre one, but we're just going to save the output to a different location, to the post folder. You see the data coming in there. So it's being populated, which is great. So refresh that. We've got all of our data. Yeah, so that's all good. Right, so it's kind of, yeah, same files as we got before, slightly different data in there because obviously we've taken down one of those interfaces. Now, this is the cool thing, right? Now, this is where the Genie Diff comes in. So the Genie Diff is now going to compare all of those files, mainly those files containing that structured data. So within our shell script here, we've got the Pi ATS diff, using that Genie Diff, and we're going to tell it about the 2 different folders, so the pre and the post, and we're going to tell it to give us the differential results within this folder here. Yeah. So if we go back, Genie Diff compare, and then what we get a result folder, and now we can see all of the differences. So go into here, So for the interface, the differences between the interfaces from that learn, you mainly see here, we've got the enable, true, and false, some other differences. And as we go through, you'll see that it tells us, differences about the, the OSPF, the adjacencies, the routes that are now changed, everything that's changed within that network. So it kind of gives us a real nice clear visibility into what's happened within the network between those two different snapshots. So yeah, kind of ideal for maintenances. Cool. So those are the two demos that I wanted to show you. Cool. So yeah, thanks for viewing. Appreciate everyone coming along. I appreciate you kind of spending your time listening to me talk about Pi ATS. I hope you found it useful. And yeah, great. So good stuff. Well, enjoy the rest of your day, and thanks again.